Geometry lesson, ASA, angle, side angle, triangle congruence. Okay, guys, why don't you take a moment and try to warm up and pause the video and answer the questions, please. Thank you. Okay, guys, here it is. The question was, determine whether the triangles are congruent. One of the things that you would do is that you would use the fact that triangle has interior sum of 180 degrees, and when you do that, you end up with this, right? 180 minus 45 plus 61 gives 74 degrees. You do something similar. This one, you don't even actually have to do that because you know that 74 and 61 plus 45 adds up to 180. Because we have 74 and 61 already, this one has to be 45. So first thing that we could do is that all angles are congruent. Triangle have the same shape, but not necessarily the same size. So in order for something to be congruent, the triangle that is, right? All the angles has to be congruent and all the segments has to be congruent. Now, the additional information that we have is that the side opposite the 74 degrees is 2.3. So the question here is are all segments one pair of, are they all congruent? And the answer is yes. It's because if they're similar, the ratio of this to this has to be same as this to this. If that's the case, whatever 2.3 is, right, because they're the same, these has to be the same. For the similar reason, these has to be the same. All right, let me say that one more time, okay? The angles over here indicates that there are similar triangles. The similar triangles, for example, has the ratios that are the same, right? The ratio of the sides are the same, meaning, let's say AB divided by AC has to equal to ED divided by DF. If I set that up over here, we know that the AB and DE are the same. You all see that? So these are the same. For the same reasoning, we do the BC over 2.3, EF over 2.3 has to be the same. And from there, we could see that BC and EF are congruent. That being said, all three sides has to be the same. So by the definition of congruence, congruent triangles, they have to be congruent, right? That's it, guys. I think what we just did is that we just proved angle side angle theorem, right? In other words, if two corresponding triangles have two angles, see that? Two angles right there. And in the middle is a side that's the same, right? So we got angle side angle is equal to the angle side angle, then those two triangles are congruent. Sounds good? All right, guys. All right, so looking at this right here, guys. So could you write this down, please? So what we're doing is we're defining congruent triangles in 5.1, right? Subsequently, this is what we're doing, okay? So angle side angle, could you write that up, please? This is angle side angle. Triangle congruence theorem says that if the two angles and the included side of the angles are congruent to the two angles and the included sides of another triangle, right, then the triangles are congruent. So looking at this, do you think these are congruent? Let's check it out. Okay. Over here, we have 68 and 33. Hold on. We have 68 and 81. Then what's the angle here? As it turns out, that should be 31. Well, now that we found that angle, compare this, guys. I got 68, 26, and 31. 68, 26. So far, so good. Because the angle is different. Just imagine for a second, guys. If this was 31 degrees, if 30 33 degrees would look like this, right? Right. If that was 33 right there, it would clearly give you a different triangle, right? Right. So here, the third angle of triangle DEF, right, is that the measure of the angle F is 180 minus 68 plus 81 is 31 degrees. So I'm supporting the work right there, okay? Now, once we've done that, that's the first thing that we did, right? The second thing that we did was, hey, let's check it out. Well, triangle ABC is not drawing a diagonal across the congruent side means that they're not congruent, right? To triangle DEF, right? Why? Because angle C, see that, guys? Angle C and F match up, right? Watch this again, guys. A, B, C became A to B had 68, B to C had 33. For that same reason, DE has 68 and the EF right there has 31. So you have to match them up. And C and F, they have different angles, right? According to the definition, all the corresponding angle and the sides must be congruent if the two triangles are congruent. Okay, guys? All right. All right, so let's move on to the next set of questions. Here we go. I believe it's this one right there. There you go. All right, so we are doing a proof right now. Proving triangles are congruent using angle side angle, triangle congruence. Okay, in this particular one, the given information is A and C are congruent. So instead of, let me just mark it up from fresh. Instead of just going through it, you want to mark it up. So A and C are congruent. And then E is the midpoint of AC. What does that imply, guys? The midpoint divides the segment AC, that should be segment sign right there, segment into two equal parts. That means that AE and EF are the same. Okay, let's write down the given information. Number one was given to us. Number two was given to us. But the consequence of the number two was that a segment AE and CE were congruent. That right there, guys, you could simply say is the definition of midpoint. Or actually write out the definition of the midpoint, which is to say midpoint divides a segment into two congruent segments. Sorry for such a messy handwriting. All right, guys. And then what else do you notice, guys? Do you notice anything else different? If you said that angle AEB and angle CED were congruent, you're absolutely right. And because why? They're vertical angles, right? So you can say a vertical angle. You can say a vertical angle theorem, or say vertical angles are congruent, okay? Now here we show that the angle is equal to each other. And then here we said the angle is equal to each other. Here we show that side is equal to each other, right? Let's look at the triangle AEB with CED. So the first angle is A. See that A and C are congruent. Angle in the last angle, B and the D. No, that's not the one that we're looking at. We're looking at actually the E, AEB, right? AEB is congruent to CED. CED right here. Okay, they're congruent. And then right in between those two angles, we have length AE right here and CE are congruent. Do you see that? I just matched up every part. So what we could say now is that those two triangles are congruent by angle side angle. Angle side angle congruent triangle theorem. Okay, guys? All right. Now, what you could do now is try your turn. All right. Why don't you pause the video and give your best effort. All right, guys. I'm going to assume that you have already tried this, and here are the answers. I'm not going to explain it right now. I will talk about it in class. Okay. But for number 8, though, it's when you have an overlapping triangle like this, it's a good idea to either use a color to look at it or separate them out like this. You can see them much easier visually if you do it that way. Okay. All right, guys, that is it, and I'll see you in class tomorrow. Okay. All right, guys. Have a good night.